more theorem here, and then we'll look at a problem. So this is the factor theorem. The next one is called the remainder theorem. Again, only in the situation in which I have p of x divided by x minus a. So this is the key. If I have a situation like this in which I divide a polynomial by x minus a, the remainder of this division is p of a. So I'm saying this to you. If you're not interested to find the quotient, and let's say you're only interested to see whether x minus a is a factor of p of x, all you have to do is replace x by a. And if the answer is 0, then you will say x minus a is a factor. So let me give you an example. So let's say I have x cubed minus 1 divided by x minus 1. Can anyone read p of x? Awesome, thank you. Second question. Can I use synthetic division in such a situation? It's x minus a in the denominator and any polynomial at the top. Of course. I can use synthetic division, right? Okay, very good. So I can use synthetic division. Now my next question is this. Assuming I do not care about the quotient, I only care about the remainder. I take this polynomial and replace x by a. How much is a in this expression? 1. So if p of 1, if p of 1 is 0, what will I say about x minus 1? It's a factor of x cubed minus 1. What if, I don't know, what if p of 1 is 5? I don't know, we haven't calculated it yet. X minus 1 is not a factor. That's what these two, that's when these two theorems come into play. Okay, so let's determine p of 1. Can anyone tell us how much is p of 1? Yes, 1 cubed minus 1 is 0. So this is true. P of 1 is 0. So then what do I conclude? It means that x minus 1 is a, say it again, factor of p of x, which is x cubed minus 1, indeed.
So you're saying when we want to determine, are you saying like if you want to determine if it's a factor theorem or a remainder, that's how
Yes, yes, because, very good question. Why? Because I only want to know whether x minus 1 is a factor of the numerator. I don't care about the quotient. I don't want to waste my time with a long division. I don't want to waste my time with synthetic division because it takes a while. I only care to know whether the remainder is 0. So all I have to do, but only in these situations, do not correct anything. If I have this, I cannot use the theorems. Well, I could factor this and I could use it twice, but the idea is if I can apply the synthetic division, then these two theorems hold. If I cannot apply the synthetic division, like for example, like x cubed minus 1 over x squared plus 2x plus 5 or 4, here I cannot apply the synthetic division. Because I cannot apply the synthetic division, I cannot use the factor theorem and I cannot use the remainder theorem. So all these three are very close connected. Synthetic division, remainder theorem, and factor theorem. Okay, let's look at another example. And I would like to go back to the problem that we just did. This one. A minute ago we did this, right? So we looked at this division. Yes, after we rearranged it, correct. Assuming I don't care to find the quotient, how will I find the remainder of this division? If the remainder is 0, I will say x minus 2 is a factor of the top. But how do I determine just the remainder without wasting my time with the long division and the synthetic division? Yes, because I have it. But assuming I don't, how will I determine just the remainder for this?
Find the P of that and be a positive 2?
Exactly. A. So the denominator is x minus a. So a is 2. If I had x plus 5, then I would have determined p of negative 5. So I always compare it to x minus a to identify a. Very good. So that's all I have to do. So let's do it. So the polynomial was p of x equals 10 x to the 4th minus 3x cubed plus 5x squared and plus 4. And I want to determine one more time p of, we already know what a is. 2. Very good. What should the answer be? 170. If the answer is not 170, we made an error before. Unlikely, because we solved it with 2 different methods. So let's give it a shot. 10, 2 to the 4th minus 3 times 2 to the 3rd plus 5 times 2 squared plus 4. 2 to the 4th is 16. 16 times 10, 160. 2 to the 3rd, 8. 3 times 8, 24. 2 squared, 4. 4 times 5, 20. 20 plus 4, 24. What is the answer? We got 170. Yes. Okay, I messed up here. So it's 163, 24. I probably didn't copy the problem correctly. So 10x to the 4th minus 3x cubed. Okay. It has to be the same number. Okay. So this is 16, correct? 160. 20 plus 4, 24. I did copy the problem correctly, right? No.
Now 78 times 2 is not 166, 156.
That's why. Thank you. Thank you. Thank you.
Okay, we're all done.
Thank you. Thank you. Thank you. Very good. Thank you. Okay, what do we conclude? Is x minus 2 a factor of this polynomial?
No.
No, because the remainder is not, because because the remainder is not,
Not 0.
it's not 0. The remainder must be 0. If the remainder is not 0, then there is no, that x minus 2 is not a factor. Any questions for me? Is this okay? Which one? Well, I know you can say everything. You're hiding now. Okay, so let's choose another problem. On page, my book is buried in here. Here it is. Okay, so on page 393. We have x to the fourth minus 256 divided by x minus 4. I only want to know if x minus 4 is a factor of the numerator. I don't care for the quotient. I only want to know if it's a factor. What would you do? First, you will have to ask yourselves, can I apply synthetic division here? Because if the answer is no, then we cannot do what we want to do. Can I apply synthetic division here? Good. So the polynomial at the top is x to the fourth minus 256. How do I just determine the remainder? Actually, I want to know if x minus 4 is a factor of the numerator. And I only need the remainder.
P of A,
Yes. So P of?
4.
Exactly. So 4 to the fourth minus 256.
4 to the 4th is 256.
What do I conclude about x minus 4? Must be a factor of x to the fourth minus 256 of this polynomial. Any questions?
Okay, I just want to make sure I'm clear on this.
Yes?
So the one where we got 160, that's not a factor, so that means that it's the remainder theorem?
Very good. The remainder theorem says if you can, on a division, if you can apply the synthetic division, you can determine if you only need the remainder, you can determine it by plugging 4 in P of x. Now, the factor theorem says if the remainder is 0, then x minus 4 is a factor of the top. Is that better?
Not really, but I'll talk to you after class.
Let me say it one more time. If in a situation like this, if I can apply the synthetic division, in other words, if the denominator is x plus 5, x minus 3, x plus 2, x plus 1/2 even, then in many situations, I'm interested to know whether x minus 4 is a factor of the top. But I don't care for the quotient. I don't need to know the quotient. The quotient will have degree 3. I don't care for the quotient. I only need to quickly know whether x minus 4 is a factor of the top. The remainder theorem says this: if you only need the quotient, if you only need the remainder, plug in 4 and get the remainder.
Oh, okay, I get it.
So and now the factor theorem says this: if you determine the remainder and it's 0, then x minus 4 is a factor of the top.
Okay.
Better?
Yes.
Awesome. We need to look at another problem. Yes? Okay, one more. Very good. So let's take a look at, I'm looking at the same page. Yeah, 20, which one? Did you find something? Did you find something? 27, in that case. So x to the fifth plus x cubed minus 2 divided by x minus 1. So here's the question. Can I apply synthetic division here?
Mm-hmm.
Yes. In that case, I'm only interested to know whether x minus 1 is a factor of x to the fifth plus x cubed minus 2. What do I do?
P of A.
Yes, which means P of 1. If the answer is 0, what will I conclude about x minus 1? It's a factor of x to the fifth plus x cubed minus 2. So when you plug in 1, what do you get?
2. Oh, so eventually 2.
1 plus 1 minus 2. 0. So then I conclude x minus 1 is a factor of x to the fifth plus x cubed minus 2. Why? Because we determined that the remainder is 0. However, if I have something like this in the x to the fifth plus x cubed minus 2 over x squared plus 3, I cannot say that I can apply synthetic division here. I have no way of determining the remainder unless I use the long division. And I cannot determine whether from the get-go, like we did here in a blink, I cannot determine whether this is a factor. It could be that x squared plus 3 is a factor of the top, but I have no way of applying the remainder theorem or the factor theorem or plug in 3, or I'm sorry, negative 3. There is no way, because synthetic division is not applicable here. Better? Okay, very good. Other questions from me? I have a classwork for you that you take home. And you return it to me when we come back on Tuesday. So I'm going to give you what I would like you to work on right now. This is for right now. No, this one is for right now. And there is one to take home.
We're not come back till next, not next.
On the following Tuesday, not this coming Tuesday. Okay, so this is for now. So start, and then I'll give you, oh, sorry.